Okay, so in this video, we will focus on linear functions, all things linear functions, beginning with slope. Your slope formula is m equals y2 minus y1 over x2 minus x1. That's what we use to find the slope between 2 points. Also, we have the very famous formula which is called slope intercept. And that's the formula that goes y equals mx plus b. Y equals mx plus b, where m is the slope and where b is the y-intercept of the line. That's what m and b are. So slope formula is there. Slope intercept is there. There are two more things that you should know. We have point slope. So jot all this down. Point slope is the one that goes like this. It goes y minus y1 equals m times x minus x1, where m is, again, the slope. And then any point that is on a line, any point, those coordinates could go in and replace x1 and y1 respectively. So this is point slope. And then the third and final form of a line, we have what they call, I guess you can call it standard form. Standard form. And standard form looks like this. AX plus BY equals C. And here we prefer that A, B, and C are integers. Integers. A, B, and C, we prefer that they be integers. So you have four formulas. One, your slope formula, and then you have three different versions of lines. Let's do examples with each of these four formulas, and that'll be it for today. So, example. Find the slope between colon. Example A. Let's say I'll give you 2 points. Let's go to -5 and -1, 4. We have 2 points. Let's just find the slope and nothing else. So m equals, and if you wanted to, you could label. Look, you could call this x1, y1, x2, y2. You could totally label them. That's an option. Because once it's labeled, then you can just plug in the numbers where they belong. So it would be y2 minus y1 over x2 minus x1. Type that into your Casio calculator. That would be what, like 9 over -3, which just equals a -3 for your slope. -3. That's example A. Let's do a couple more, then we'll do something else. So for example B, let's say you have these 2 points. Let's go with 7, -4 and -1, -4. Well, you can label them if you want. X1, Y1, X2, Y2. You don't have to, but you can. And if you label them, and if you plug stuff in, you would get back -4 minus -4 over -1 minus 7. So here we would get back 0 divided by -8. Type that into your calculators. It, of course, would be 0. Okay, one more, and then we'll start to graph things. So example C, what about if you have, let's say, 3, -1 and 3, 4. Find the slope between these 2 points. So m would equal, it would be 4 minus -1 over 3 minus 3. So here, it's 5 above 0. So if the 0 is in the bottom, we would say undefined. We would say undefined. If the 0 is in the top, like 0 over 3, 0 over -8, that's 0 if it's on top. But if it's in the bottom, we say undefined. So that's how you find the slope. You totally need that skill as we move on with this lesson. So another example. Write the equation of the line in let's go with slope intercept first. In slope intercept form. So they're going to give you a picture, and from the picture you give them the equation of the line. So your picture looks like this. This is how you'll see it on your classwork and your test next week. It'll be something like that. And then let's say they give you a point here, and let's say that they give you a point there, and they'll give you the coordinates of the points. This one here, suppose that is at -1, -2, and this one, let's say this is at 3, let's go with a 6 actually. Let's go with a 6, let me choose this number carefully. Just kidding. Let's go with a 7, 2. That'll work out nicer. You'll see numbers that work out kind of nicely on the classwork and on the test. So what's the goal? We want the equation of this line in y equals mx plus b form, where m is the slope, b is the y-intercept. So first find the slope m, like you did in the warm-ups. First find the slope. So m would be, and then for your labels, it doesn't really matter which ones are which. You could call this x1, y1, x2, y2, or vice versa. You'd get the same slope. So our slope would be 2 minus -2 over 7 minus -1. And that becomes 4 over 8, which is 1/2. A 1/2. Our slope m is 1/2. So let me erase some of this because I need the space. But we know the slope m is 1/2. So plug that in for m. So right now you have y equals 1/2 x plus b. All you need to do now is find b, and we're finished. B is the y-intercept. On the graph, it's this guy here. But we don't know what that point is. It's not given to us. So we have to find b a different way. And here is how you can find b. You have 2 points to pick from. It doesn't matter which point you pick. Just flip a coin if you want. Let's say I pick this point. If I pick that point, this can go in for x and y. Right there and there, so I can find b. So momentarily, let's plug 7 and 2 in for x and y. So this would say 2 equals 1/2 times 7 plus b. So this is 2 equals, half of 7 is 3.5. And then to get b alone, you subtract 3.5 from 2. So b is a -1.5. That's what b is, -1.5. Plug that back in here, and then we're finished. So final answer, now that we found b, a -1.5, just plug it back in, right? So -1.5, box it in, and we're done. A couple things. I have confidence in this answer for a few reasons. Number one, the slope was 1/2, which is positive, and this graph, this line runs in a positive direction. You see, anything that runs like that is positive. Anything that runs like this in green, that would be a negative slope. So we have positive slopes, we have negative slopes. How about this here in blue? Anything that is horizontal, let me try that again. Anything that's horizontal, that has a slope of 0. What if a line is perfectly vertical? That slope is undefined, as we discussed a moment ago. Now, another reason that I have confidence with my answer is that the y-intercept was negative, and as it should be, because in the picture, this point, it's underneath the x-axis. So everything's in agreement. There's no contradictions here. All right, let's move on. Example now. Example, write the equation of the line in, how about this time, point slope? So let me just change the directions. The goal now is to write the equation of the following picture in point slope form. So here's your given picture. It goes like this, it goes like that. Let's say it goes like this here. Actually, let's do one that's negative. Let it fall down, go like that, go like that. Put a point here, put a point there. Let's say the coordinates here are -1, 4, and this one is at 3, comma, let's go with -2. All right, so point slope. They call it point slope because you need a point and you need a slope. Let's jot down the formula. Y minus y1 equals m times x minus x1. We need the slope m. Always try to find the slope m first. Let's do that. Find the slope. M equals y2 minus y1 over x2 minus x1. This becomes -6/4, which reduces to -3/2. That's our slope. -3/2. I believe that it's negative because look at the picture. It falls down from left to right. So throw that back in for m, -3/2. So here's what we have so far. Y minus y1 equals -3/2 times x minus x1. Now the last step is this. Plug in any point that you have into x1, y1, and you're finished. I have 2 points to pick from. It doesn't matter which point you select. Let's say I pick this one here. Plug in its coordinates, not for x and y, but for x1 and y1. There and there, respectively. Let's see what that would look like. This would become y minus -2 equals -3/2 x minus 3. And you know what? You're done with this example because the goal was point slope. That's point slope. Move on to the next question. Hey, what if the person next to you had used the other point instead? Their answer would have looked different, but I would have accepted both answers because they're both correct. And if you graph them both on Desmos, you would only see one graph because they overlap, because it's the same line. Let's do one with standard this time. So write the equation of the line in standard form. Standard form. So let's say you're given this picture here, form. The picture looks like this time. Let's go like that. Let's go kind of like this here. And let's say this time they actually give you the y-intercept. And let's say they give you a random point out there. Let's say this is at 0, -2. And let's make this like 10, 4. Just making up numbers. Well, what does standard form look like? Standard form looks like ax plus by equals c. Notice m is not part of that equation. It's not like literally written within it, m. But what we can do, if you want, we can begin here. Look, let me even switch colors. If you want, we could go y equals mx plus b. And then from that, we can convert it into standard. That's a common process that sometimes students use. They go from slope intercept to standard. So why don't we do that? Let's go y equals mx plus b, then we'll go into this and then we'll be done with this example. So first, find the slope m. M would be y2 minus y1 over x2 minus x1. So we get back, what is this? 4 plus 2 is 6/10, which reduces to 3/5, 3/5. Yeah, 3/5 is our slope m. So m is 3/5. Throw that back in for m. M is 3/5. So y equals 3/5 x plus b. Now recall b is the y-intercept. And voila, the y-intercept, it's given to you. It's right there. So -2 goes in for b. It's convenient. Y equals 3/5x minus 2. Now, to turn this into standard, observe that standard form, your x's and your y's, they're both on the left-hand side. So in our y equals mx plus b down here, how about we subtract the 3/5 x to the other side? So it would become minus 3/5 x plus y equals -2. So we have the correct order. X is first, then the y's, and then the constant c by itself over there. The only thing left is, recall in your notes, we said integers. We said that for standard form, a, b, and c must be integers. Here, the 3/5 isn't. So to undo that, you can simply just multiply both sides by the denominator, 5. Multiply every one in that equation by 5 times both sides by 5. So we would get minus 3x plus 5y equals a -10. That is totally acceptable. Is it okay if the number in the front is negative? That is acceptable. That's totally fine. If it's negative, you can leave it. If you want to make it positive, you'd have to multiply everything by a negative, and that would also be okay. But you don't have to. You can just totally leave it like that. All right, last example for the video, and then we'll continue on Monday morning. So one last example. How about something like this? What if instead of they give you the picture, you have to make the picture? We haven't done that at all. So how about like this? Sketch the graph. Yeah, we have to make sure we can sketch for ourselves. Sketch the graph of, so let's do like ABC. We'll make this quick. How about y equals, let's go with 3/4x minus 2. So this is slope-intercept form. So here, go to the x-axis. Go like 5 spaces each way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 spaces each way. And then you can begin with B, the y-intercept. Here, if it's -2, go down to -2 on the y-axis and put a point there. Now from there, remember your slope? A loose definition that you probably remember from middle school is that slope could be viewed as rise over run. So from your y-intercept, you could rise 3 and you can run 4. Run to the right, 4. So from the y-intercept, go up 3, 1, 2, 3, 1, 2, 3, 4. You run 4. Play connect the dots, and you're done. That's all there is to it. If you're in slope intercept form. Let's do one more of that sort. So we'll do ABC, and then we'll finish the video. So that was A. Let's try B. How about y equals, let's say minus 5x plus, how about, let's say 4 this time. Yeah, let's see. So let's go like this. Let's go like that. Let's go 5 spaces each way. So begin with the y-intercept, which is at +4. So 1, 2, 3, 4. And then the slope, we're accustomed to seeing it as a fraction, but it just says -5. Well, you know that underneath, you could put a 1. You could always put a 1 if you want. And then, so from the y-intercept, go down 5 and still to the right 1. Still to the right. So 1, 2, 3, 4, 5 over 1. Play connect the dots. And it is a very steep Very steep graph, -5. Done. That's the graph of that line. How about, what if you have one like this? What if you have one that says something like, let's say 4x minus 8y equals 12? Something that's in standard. I'll show you the fastest way to do this. Why don't you write down x int? Why don't you write down y int? X-intercept, y-intercept. Here is what we do. If you want to find the x-intercept, use your hand, use your fingers, and cover up the y's. Cover up the y's. And then if you want to find the x, cover up the y's. All I see is that. So then get x alone. Divide by 4. 12 divided by 4 is 3. So my x-intercept would be 3. That's all you have to do to find the intercepts. So now let me actually undo the scribble. So we know for sure that the x-intercept is 3. So now do the same thing for the y's. If you want to find the y-intercept, go ahead and pretend that the x's aren't there. So now go 12 divided by -8. 12 divided by -8, that'll reduce down to -3/2, which is a -1.5. So you have your x and your y intercepts, respectively. Go to the x and y axes, go to 3 for the x-intercept, and put a point there. Go to -1.5 on the y-axis, and put a point there. And then play connect the dots. So if you're given standard form, and you want to graph, use the cover-up method. Cover the x's to find the y, cover the y to find the x. You'll get your 2 intercepts, then you can plot the 2 points, connect the dots. So we do have more examples of this to learn, but we will do those examples early Monday morning. I'll see you guys then. Have a wonderful weekend.